Welcome back. This is an Aleks homework video on organization of the periodic table. You must have a periodic table with you or my voice is not going to help you at all. You won't understand a word because I'm referring directly to the periodic table. Okay, so these are simply questions. Do you understand how the periodic table works? And so they're asking you questions, and if you do, then you'll answer them correctly. If you don't, you'll have no idea what the questions are saying. So the only way I know to do it is just do it one at a time. First one says an element in period 1 and group 2A. Well, if you look at the periodic table, the second column is group 2A, and where there should be an element there in group right beside hydrogen, where it would be helium, it's not there. Helium is actually all the way over in group 8. The reason why it's in group 8 is because it acts like a noble gas. It is a gas, first of all, and it has a full valence shell. So it behaves way more like neon and argon and krypton than it does calcium. So for that reason, it's not put in group 2A. So even though there is an element 1 above hydrogen that should go there, there isn't one there. So when you look at the periodic table, there's like a stair step there where you've got a missing box. So the first one says, is there a period 1 in group 2A? No, there isn't. So since there's not, I'm not going to give you a symbol there because there isn't one. Okay. The second one says a semi-metal. A semi-metal, there's another word for it. I think your textbook says metalloid. A metalloid in group 8A. A metalloid is anything that touches the stair step. The stair tread, which starts to the side of boron in group 3, goes under boron, beside silicon in group 4, under silicon, beside antimony or arsenic in group 5, under arsenic, beside tellurium in group 6, under tellurium, beside acetine in group 7. Anything that touches those stairs on the top or bottom of the stairs are called a metalloid. And they act somewhat like metals. They could conduct electricity, or they can act like nonmetals and actually be an insulator to electricity. So, for instance, germanium and silicon, these metalloids make beautiful computer chips because they would resist electricity and act like an insulator. But if you scratch it, you can actually, it acts like a wire and will conduct electricity. That's why you can have teeny tiny little computers in your cell phone that's bigger than the computer that went to the moon. So a metalloid is anything touching those stairs. And there are no stairs in group 8A. 8A is the noble gases. There's no metalloids in the noble gases. They're all nonmetals. So this would also be no. Third one says a halogen with a higher atomic number than oxygen. Okay, halogens are anything in group 6A. So the top of the group 6A is oxygen. Under oxygen is sulfur. Under sulfur is selenium. And these sulfur, selenium, tellurium, they have a higher atomic number than oxygen. Okay, so I would say yes, they would have a higher one than oxygen. I'm very sorry, I'm pretty stupid. Halogens. No, I made a mistake. Halogens are group 7. So halogens would be fluorine, chlorine, bromine, and iodine. But fluorine is a halogen, and it has a higher atomic number than oxygen. Oxygen has an atomic number of 8, and fluorine has an atomic number of 9. So that would be what that is. The group 6A is called chalcogens. I just got it all confused. I'm sorry. Okay, the last one, a transition element in period 6. The transition elements are the ones from like scandium to zinc, those ones that are kind of dipped in the middle, the valley in the middle of the periodic table. So it looks like the third column all the way to the to the 12th column would be the transition metals. So transition metals are actually 2 removed. Or or 1 removed. So scandium looks like it's in group 4, but it's actually in group 3. I'll try to explain that another time. So since there is what appears to be group 7, is 1 up would be in group 6, period 6, it would work, yes. So which one would it be? Okay, it's the 2 at the bottom of the periodic table, and they would be, the first one in group 6 would be the lanthanum, so that's the lanthanide series, and the actinide series, the two rows at the bottom of the periodic table. The first one is actually the transition metals for 6, and the second one, the actinide, is the transition metals for 7. So this one is going to take some work for you to understand it, but ask me in class.